you're almost never going to have just the LLM task or like the call to the agent being the only part of your workflow. Like you're probably starting way earlier than that with raw data from a bunch of different sources.
That's Kenten Danas, Senior Manager of Developer Relations at Astronomer, reminding us of a simple yet critical truth. Before AI, before agent workflows, before models, your data pipelines have to work. In this episode, I sit down with Kenten to unpack why Apache Airflow has become one of the most important tools in the modern data stack, not just for data engineers, but anyone who needs to move, monitor, and manage complex workflows. We start with a little bit of history.
Airflow is an open source tool for authoring, scheduling, and monitoring data pipelines. It was originally developed inside of Airbnb back in 2014. Frequently see it have more than 30 million downloads a month.
But this isn't just a history lesson. We get into what makes Airflow adaptable, especially for geospatial, AI, and machine learning pipelines.
One of the reasons, at least in my opinion, that it's so popular is that your data pipelines are written in Python. Airflow itself, everything in the project is written in Python, and then when you develop your pipelines, or they're referred to as DAGs, those are all written in Python code, so you can manage your pipelines just like you would any other software.
We also dive into one of the hottest topics right now, how Airflow fits into LLM ops and agentic workflows.
Agents, sometimes automate little bits and pieces of those workflows, but they're probably not automating the whole thing from end to end. And they're also, typically, at least right now, kind of a black box.
Plus, if you're working with spatial data or building complex batch jobs, Kenten shares some real-world examples of Airflow being used in climate risk modeling and geospatial analysis.
All of this they are managing using Airflow. So they're orchestrating workflows where they're bringing in data from a variety of different sources, and then they're feeding it through these predictive models that are then used to create their end product.
So whether you're running your first DAG, scaling up AI-powered pipelines, or trying to tame the chaos of geospatial data, this episode is packed with insights you'll want to take notes on. The future is spatial, so let's get into it. All right, Kenten, welcome to the show. I'm excited to have you here and to introduce, the listeners a little bit to Airflow pipelines and some of the tools that are used in the modern data stack to move data around. But with that, I'll let you do a quick introduction, and then we can kind of kick it off from there.
Yeah, thanks so much, Matt. It's great to be here. For you to have me on. For introduction, I'm Kenten Danas. I'm a senior manager of developer relations at Astronomer. I've been working with Airflow for a long time. I have a data engineering and data science background myself, and my role now is very focused on helping folks use Airflow and Astronomer's products.
Great. So I guess maybe we can start with a little bit about Airflow. I know a
Yeah.
little bit about the history of the open source project, and then obviously Astronomer, which came out of that. But if you could give us a kind of a quick, brief history lesson, and then kind of understand how it's used both in all those practice areas, because I know Airflow can be applicable for data engineering, data science,
Yeah.
lots of different ways to do that. And for context, I think Geospatial has hacked together geospatial pipelines for a long time, amongst a lot of different tools. So I'm excited to kind of help this audience really understand some of the details around, okay, how is the rest of the world doing this? So if you could jump in there, I think that would help kind of frame it. And
Yeah, absolutely. I love chatting about Airflow history. So for those who are completely unfamiliar, Airflow is an open source tool for authoring, scheduling, and monitoring data pipelines. So you often hear it referred to as a data orchestrator. It was originally developed inside of Airbnb back in 2014, and then was open sourced. It became a top-level Apache Software Foundation project in 2019. And then Airflow has evolved quite a bit since then. So Airflow 3, which we might get into a little bit later, was just released a couple months ago. So that was a big major release in the project's history. Happy to dive into Airflow features, but generally I think of Airflow is one of the most popular data orchestrators used around the world. We frequently see it have more than 30 million downloads a month, which is, pretty crazy. It's used kind of in every different industry and by companies of all different sizes. One of the reasons, at least in my opinion, that it's so popular is that It's kind of purpose built to be really flexible for any use case. So, a core tenet of Airflow when it was first developed that kind of set it apart from some legacy schedulers or orchestrators was that your data pipelines are written in Python. Airflow itself, everything in the project is written in Python. And then when you develop your pipelines, or they're referred to as DAGs, so I might slip into saying that throughout, those are all written in Python code. So you can manage your pipelines just like you would any other software. And you can also then kind of leverage like anything that you can do in Python to implement that within your tasks. And then, Airflow itself has a lot of features that have been added on top of it. To again make it super flexible for a lot of different use cases. So historically, we did see Airflow used a lot for kind of the traditional like ETL for analytics use cases. I think that's still kind of a bread and butter thing. Astronomer does that ourselves. A lot of analytics teams internally will use Airflow for things like that, managing the data that feeds their dashboards. But in the past, I would say 5 years or so, there's been a really big expansion in terms of Airflow being used for other use cases. So you mentioned like data science, kind of that ML ops space and managing models and all of the data preparation that goes into use cases like that. And then, of course, in the last kind of couple of years, the LLM ops space. So managing LLM workflows, AI workflows, anything with agents. Airflow is great for all of that. We see it used in those places as well.
Yeah. So I know there's a few terms that are important in the Airflow world, and even in the broader data pipeline world. So I know you mentioned DAG, and I know I think directed and graph, and I'm going to mispronounce the A within that. But I think if we want to, could you talk a little bit about some of those like fundamental building blocks that you find in Airflow, and kind of what makes them unique or special, or why they're important?
Yeah, absolutely. So, from the perspective of like somebody who is writing the data pipeline, so usually a data engineer or a data scientist, the most kind of core concept within Airflow is called a DAG. That is just your data pipeline. It stands for directed acyclic graph. That is a mathematical concept that exists, beyond just Airflow, and I kind of tell people to not pay too much attention to that. You can just think of it as your data pipeline. So it's going to be written in Python and then registered within Airflow as a DAG. That is your pipeline that you run. Within that DAG, you're going to have tasks. So if you are thinking about it from the mathematical sense as a graph, that's going to be your node. So we recommend that each task is an atomic unit of work. So what that is will vary widely depending on what your use case is. But within Airflow, you will have, maybe just one task in a DAG. It might also be thousands of tasks, kind of whatever you need it to be. And then when you run that DAG within Airflow, you'll generate a DAG run. And within that run, you'll have task instances. So that's kind of what happened within that task as it ran at a point in time. There are lots of other concepts we can dig into kind of more on the authoring side of like how you create these DAGs or data pipelines. The first one I always touch on with folks are operators and decorators. So if you were to actually look at the code that creates a DAG in Airflow, when you define a task, you're going to use either an operator or a decorator. They do very similar things, just kind of different implementations. An operator is kind of like the building block of Airflow. And again, I mentioned these are all written in Python. So if you want to just write a Python script that does something, whatever you want your task to do, you can absolutely do that. And then you would typically throw just a task decorator on it that just turns that Python function into a task in your DAG. You can also, because Airflow is so popular and has so many contributors, lots of people have written, kind of boilerplate tasks so that you only have to provide the configuration. So if you need to say execute a query in your data warehouse, be it Snowflake or BigQuery or Redshift or whatever it is, you don't necessarily need to like write the Python code to, make the connection to that database and create the client and all of that. Somebody else has done that for you. So that's essentially what operators are. So they're just a Python function that you would import into your DAG, and it has all of that code already built for you, so that you can just provide the query you want to run. So again, super flexible in how you implement it, but those are kind of the basic building blocks. And then beyond that, you would start getting into like the configuration that you need for your pipeline. So of course, Airflow can do all of the managing of connections that are needed to, authenticate Airflow to the other systems where you're moving data in and out. Um, it can manage, dependencies between your tasks or between different pipelines. It can manage what happens when failures occur. So, do you want tasks to retry? Do you want notifications to be sent? All of that good stuff is all baked in.
Yeah, but that was one of the things I really enjoyed, like, my first time using Airflow, was, I had a basic idea what I wanted to do. And of course, like, well, I could write this in Python, but I need something to manage this, right?
Yeah.
And then other things started popping up that could see that I wanted to do. Well, okay, this step might fail. What do I want to do with that? Do I want to,
Yeah.
how can I handle that? Do I want to know about it? Do I not want to know about it? And then, within the Airflow UI, you get this really rich view of seeing all the things that are going on, errors. It makes for a really nice experience just to be able to, develop, but then also kind of
Yeah.
see and track and monitor results. And I know Airflow 3 got a big upgrade there, in terms of user interface, which looks really nice. So I watched a nice video on YouTube going through everything on that, and I was like, wow,
Right.
this is looking really good. So I think, as most data pipelines might start off small. I think some projects are,
Sure.
hey, I need to do these things, but over time, of course, they grow, and then you have all these other orchestration pieces around that. What are some of the things that within Airflow really help you manage both the data and the dependencies as the scope and complexity grows, especially as you get into, like you said, ML ops use cases,
Yeah.
feeding data to LLMs. You get these really, start more advanced use cases from just, hey, I need to move, a CSV to somewhere and do something with it there. What are some of the pieces built in that help support those, kind of continually growing and complex use cases?
Yeah, definitely. There's, a couple of different things that come to mind, lots of features that are applicable here. One thing I will mention is just scaling Airflow itself. So this is something where I always hope that people who are actually writing, DAGs or data pipelines in Airflow don't have to think about this too much, but Airflow does have components that need to be run, just to make it work. And those are all built to scale. So of course you can do that yourself, or you can use a managed service like Astronomer, or however you're doing that. Though that is, something that's really, really powerful, and that is a big thing that has evolved in Airflow over the years to make it just better for like large enterprises who are running, thousands or tens of thousands of these DAGs, for more complex use cases. So again, it's a little bit more like under the hood, but that is one piece of it that I think has contributed to its popularity. In terms of things that you would actually interact with more as the person writing the data pipelines, a couple of features that I think are really relevant for especially the more complex, like MLOps and AI use cases, are the ability to make your pipelines more dynamic. So oftentimes you might need to have them adapt to something that's happening at runtime. In the MLOps world, it's often like parameter tuning models where you might not know ahead of time like what all of those parameters are or which ones you want to move forward with at any particular step. Airflow has features built in for that. Dynamic task mapping is one of the biggest ones that allows you to sort of set up the structure of your DAG ahead of time, but then have it figure out every time it runs, okay, how many copies of this task do I need? Um, so that's one thing. Another thing is on the scalability aspect, there's a lot that I could get into here, but in terms of like really heavily processing data, a new thing in Airflow 3 is remote execution. So one of the things in Airflow generally is you need to think about how you're going to run your tasks, and you have a couple of different options there for what you implement. On the Airflow side, that's called an executor that you would choose. So are you going to run each task in a Kubernetes pod? Are you going to use Celery workers? Those are some existing options that have always been there. With Airflow 3, you now also have the option of using remote execution, which means you're going to run your tasks on infrastructure that is completely separate from where Airflow itself is running. And one of the great things about that is for more complex use cases, especially those in like the ML and AI space where you might need pretty heavy duty compute to support all of that data that you're processing. You can do that for the tasks that you need. So you can say, I'm going to send these tasks to like a GPU cluster somewhere, even though you almost certainly don't want to be running your Airflow instance on a GPU. I think that would be not very efficient resource-wise. So that is something, again, new in Airflow 3 that was one of the reasons that feature was developed, was, again, to support kind of more complex use cases like that.
Yeah, the within the geospatial world, there's a lot of like batch processing. So you have these like heavy data files, and oftentimes you need to figure out ways to either split them up or kind of move them efficiently. And what I found was really nice about Airflow is that there's all this connectivity, right? It has the ability to go into all these different pieces, both data warehouses, storage, open source projects, and be able to communicate across those things. And then you get that like clear historical view, especially if that's super important to see all those things that are happening. So like one pipeline that I was working on, there's a data set that it measures river height around the United States, all these
Okay.
river gauges, right? And the government basically publishes it, but then they overwrite it every 15 minutes. And they have like a historical data set, but it's really hard to use, and
Yeah.
it's in a weird format. So I was like, okay, well, this seems like an easy way to do that. And what I can see is that there are periodic failures with the source data, like the source data
Yeah.
isn't updated or it's not connecting, and you can see where those things are and then account for that when you're going back into the data, which is really nice. And then as you scale or need to add more complexity, I think that is a really good feature to be able to call out to those extra resources to give it the boost and stuff like that. With it, how have you seen geospatial data being used in in the Airflow ecosystem, or with some customers you work with at Astronomer? I'm going to be pretty wide with the definition of geospatial, because I'm sure there's people that work with latitude and longitude data all the way up to
Yeah.
imagery and stuff like that. So just kind of curious to see what you've seen kind of from your perspective on geospatial use cases.
Yeah, absolutely. Great question. And I think you just touched on a little bit of, why Airflow is relevant for those use cases. A lot of what you're doing kind of behind the scenes is, again, just managing, moving data around and taking advantage of a really flexible system where you can, utilize different resources if you need to, and you can implement all of the great things that orchestration brings. One particular example that comes to mind, Astronomer has a customer who has spoken about this publicly. They're a company called Vibrant Planet. And so their mission is to, help communities and ecosystems adapt to climate change. So they help their customers understand wildfire risks and then provide actionable recommendations. So that's all enabled by the sort of data-driven scenario planning to help understand what those risks are. So of course, like in a world with more and more wildfires, this sort of thing is really important to help local governments or land managers or whoever is kind of prioritize both prevention and mitigation efforts. So this is all based on geospatial data. So, they're looking at that data to kind of help analyze the wildfire risk of an area based on, frankly, a lot of stuff that is not my area of expertise. But uh, how the land is used and forest cover and things like that. All of this they are managing using Airflow. So they're orchestrating workflows where they're bringing in data from a variety of different sources, and then they're feeding it through these predictive models that are then used to create their end product. One of the things that they have spoken about a lot with Airflow is actually some of the features that I mentioned before. So they are doing this in batches for different areas where they look at, a different kind of ecosystem, and do all of that analysis at one time, but it's broken up into kind of random chunks. And so those chunks, they don't necessarily know ahead of time what they're going to be or how they're going to change over time. So they're using things like dynamic task mapping to make those workflows more dynamic. Another thing that they have talked about publicly is that with the geospatial data that they get, like one of the challenges is that the size of that data varies enormously. So however they chunk that data, it might be like a pretty small area of land that they're analyzing, or it might be huge. And that, is again more driven by like what the ecosystem looks like. So all of the data sets that they're looking at are not created equally. And that makes it really difficult for them to use resources in a way that is efficient, because they don't want to assign like the heaviest resources to all of their tasks, because that would be really expensive. Obviously, they don't want to assign too few resources, or they're going to get like out of memory issues and their tasks are going to fail, and then they have to retry, and it just delays everything down the line. So they have, implemented kind of a cool solution using Kubernetes hot operators, where they try and predict ahead of time kind of what the resource utilization needs are going to be for each task. And again, are able to do that kind of using some of Airflow's built-in functionality and the flexibility of being able to choose different executors and where and when tasks are being run.
Yeah, that's great. I mean, it's you hit on a few things that are like unique challenges with spatial data. Is that there's, depending on what you're looking at, size can vary.
Yeah.
The task that needs to happen also varies in terms of the compute scale. Like a simple moving a file or changing a format, not terribly heavy compute.
Right.
But if you're doing maybe machine learning, if you're doing some sort of spatial feature generation for upstream machine learning, things like that, then you want to have the flexibility to choose where you run compute, and then have that one single orchestration source of truth, which is really nice. I think another question that I've gotten before is, okay, how can I get started building some pipelines? I know there's a lot of options, both from the open source perspective. I've used the Docker container before, or some Docker based versions of Airflow, and then how and when do I shift that up to the cloud? Like when do I say, okay, I need to be running this in a cloud service, and how do I do stuff like that? I think that's one common question I've gotten quite a bit, is to say, okay, well, I want to build my code locally, and I want to have an easy shift into the cloud. How can I do that?
Yeah, absolutely. So I think, working locally and developing locally is really common. And I think it's the easiest way to get started. And it eliminates, the issue of having to like write some code and then deploy it somewhere and then test it and then go back. So I always like to plug the Astro CLI is a great way for running Airflow locally, and that's a tool that Astronomer has developed to help run Airflow. It does work on like a container engine, so you can use Docker or Podman. It's much more straightforward than setting it up yourself, and it's totally open. It's free for everybody to use, so anybody can download that. And that's, again, what I always recommend for folks who are just looking to learn Airflow, is to do it that way and get started, play around with it locally, and you have kind of that instantaneous feedback when you're writing your DAGs. As soon as you are looking to actually run something that you rely on, you're not going to want it to have, you're not going to run it on your local computer anymore, right? So that's where you would be looking to actually deploy Airflow in the cloud somewhere. And of course, you have lots of different ways you can do that. One, and probably the lowest amount of effort, is using a managed service. So like Astronomer's service Astro is built on top of Airflow. We have other features on top of it as well, but the Airflow piece of it is going to be, analogous to like what you would run in open source. So if you've written pipelines in Airflow already, they will just run in the same way, and you'll have the same access to the Airflow UI. Actually doing that deployment is very easy. You can do it with the CLI. It's just one command. We often recommend for folks in production to like set up CI/CD. Again, another benefit to having just pipelines written in code in general is that you can set that up and deploy that way. So that's a little more typically reliable, and you can add tests and everything that you want to do there. Yeah, of course, there are also other ways that you can run Airflow. We do see companies deploy Airflow themselves. So all of the infrastructure is open source. If you want to like set it up to run on your own Kubernetes cluster or something like that, you certainly can. It's more work, but lots of people do that as well.
Yeah, I think that's kind of what I found when I was building some different pipelines, is that I can get all the the issues out of the way, right? Make sure it's running, make sure I have some successful runs.
Yep.
And then I didn't know the Astro CLI did local dev as well, so that's good. That's new for me. So I was
Okay.
like struggling to get my Docker containers set up, so
Yeah.
that'll save me a lot of work next time. But then yeah, it was like I could just kind of go I used Astro to basically lift it in the cloud. It's running, it's going, so then it's basically there, and I know that it's doing all the things that I needed to do from that perspective. I excuse me. As you look towards kind of some of the next things, or things that came out, I should say, because Airflow 3 is
Yeah.
a couple weeks or a month or two old now. I can't remember the exact date, but
Yeah, late
yeah,
April. Time
it,
flies, so I
I
guess
know.
more
Yeah, I
than
was
a
like,
month
I was like,
now.
that just happened. Yeah.
Yeah.
So what are some of the new and unique features in Airflow 3? I mean, I mentioned the UI. I know there's a few additional pieces, and kind of what does that mean for people kind of building pipelines, and what do people have to kind of look forward to?
Yeah, absolutely. So Airflow 3, I've been saying, has been kind of the biggest release in Airflow's history, which is really cool. We are very excited about it at Astronomer. Um, Lots of new stuff baked into a major release. Even Airflow minor releases tend to have a lot of new features, so more than you probably want to listen to me like list through here. But for the bigger things, I tend to think of it in kind of three different categories. One is like the user experience category. So that's like the Airflow UI got a huge refresh, which you already mentioned. The other big things that were like very highly community driven. So lots of folks in the community were asking for these features that were delivered in Airflow 3 on the user experience side were DAG versioning. So this is the ability to track changes in your pipeline code within the Airflow UI over time. So this is really, really helpful for management of your pipelines and again, maintaining that history, which previously, if you made a change to your DAG, it's like the old one is gone as far as Airflow is concerned. So now you can go in and again see that. Another is backfills. So this is also particularly relevant often for if you're just deploying new pipelines, but also for those kind of ML and AI use cases where you might develop a new version of your model and then need to train it on historical data. So backfills are just going to help you reprocess, DAG runs for anything in the past. This is a feature that existed in Airflow 2, but it was kind of a little wonky, I would say. Didn't quite work super well, and it wasn't very reliable. So now it's kind of a first class feature. That everybody can use, and we're already seeing a lot of excitement over that. Another big change was more on the security side, and this is kind of the under the hood with Airflow's architecture. So I talked a little bit about remote execution already, and this ability to run tasks in clusters like outside of Airflow. A lot of that was built on top of this change referred to as task isolation. So again, under the hood architectural change, something that prompted like the major version release that made it so that the workers or the processes running your tasks no longer have direct access to Airflow's metadata database. So again, this is something that, I mean, some people did implement stuff like that in their tasks. It's not the best idea, so maybe you would have to change, but hopefully this is kind of unseen for a lot of users. But it is much more secure in the way that's implemented. And again, it kind of opened the door for these features like remote execution. Um, and then the last thing is kind of more flexibility on when and where you run your tasks. So the where part is the remote execution. The when is there's a new feature called assets, which for anybody who has used Airflow 2, this is an evolution of data sets, the feature. So asset is just a collection of logically related data that you define as the user. So like in the geospatial sense, that might be, a particular like land area is an asset that you define. Gives you a lot more flexibility in terms of how you write your pipelines, but it was also used to implement event-driven scheduling. So within Airflow, most of the options for when you run your pipelines previously were either time-based, so you would implement like a cron-based schedule, like daily, weekly, whatever, or based on when other tasks or DAGs within your Airflow instance completed. Now you also have the ability to run them when something else has happened external to Airflow. So the way this is implemented right now, it's based on kind of a message queue system. So when a message arrives, your DAG will be triggered. SQS was the first system that this was implemented for. So I think really helpful for folks who want to like process, if it's geospatial like files, when they're arriving. If they're arriving at different times and you have no idea when they're going to show up, you can set it up so that, okay, when this file arrives, if it sends a message to SQS, then my DAG will run and process that data. And SQS is the first system that was implemented. There will be others that will be kind of fast follows in future minor versions. So by no means will it be limited to that in the long term. But that's, again, a really highly requested feature within Airflow, and one that we see a lot of use of already.
Yeah, the two that stood out to me were assets and backfill, because backfill is if something's missing or I need to look at that view. That's really nice that you just can see it, execute it, and I think there were a lot of options on how you do that backfill, which was really nice. And then the assets, I mean, I now that you're explaining it a little bit more, that event-driven piece, there's a lot of data sets out there that have information. I mean, there's the big one I always think of is like the NOAA storms database, is that there's this huge database of like storm events, and can you take some action based off of that? And like, this is just free data that's sitting out there. And you can actually, that's probably a future project that I want to take a look at as well. So just I'll cut this, but would you be up for, I know it's not on the agenda, but kind of doing a question on understanding how Airflow works with like the LLM agentic workflows and stuff like that? Because I know that's a hot topic in our, I think it is for everybody, but
absolutely.
Cool. Another question is kind of, you mentioned Airflow, kind of being an orchestration layer and fitting into the new world of AI, generative AI, LLMs, or agentic agent-based workflows. There's about a million names for this stuff now. Yes. But what kind of, how do you see Airflow kind of fitting into this new paradigm? Because like from my perspective, I think there's a lot of really interesting work that these agents can do, but also you need a ton of data to feed them to do the things they need to do. And of course that it does a lot for anybody working with data. So how is Airflow kind of adapting to those new needs that people are bringing forward?
Yeah, this is a great question, and one that's certainly very topical, and we're hearing a lot about with our customers at Astronomer and the folks in the Airflow community. So I think there's kind of two aspects of it that I think of. One is the one you just mentioned, which in order to like really take advantage of AI and LLMs and agents, like you really need to have good data in place first, and that's not going to happen automatically. So that orchestration layer is really, really important, just to manage all of that and then kind of tie all of it together. Another piece of that we see is like agents, sometimes automate little bits and pieces of those workflows, but they're probably not automating the whole thing from end to end. And they're also, typically, at least right now, kind of a black box. So you don't get a lot of insight into what's happening with them and how you can intervene if something goes wrong or if you need to change something. So that's where we see Airflow as, again, being kind of the key piece of like the glue that holds all of this together. Is you're almost never going to have just the LLM task or like the call to the agent being the only part of your workflow. Like you're probably starting way earlier than that with raw data from a bunch of different sources. So Airflow is going to be useful for, again, managing all of that. I often see, what is effectively kind of like an ETL pipeline that happens first, and then you move into your Gen AI workflow. The other piece of it is that, managing the AI workflows, whether that's a call to an LLM or actually orchestrating like an agent, that is done via Airflow as well. So of course, with everything written in Python, you could write a function to do that yourself. There's also some tooling that's being built to help make that easier. So Astronomer recently developed the Airflow AI SDK, and this is totally open source, so anybody can use it. And it's, a set of decorators, like I mentioned before, kind of these building blocks of your pipelines that just create a wrapper so that you can just easily provide like the prompt that you want and the model that you want to call, and you don't have to figure out all of the Python for doing it yourself. So we've seen that used a lot already and gaining a lot of traction because it just makes writing those pipelines and then managing them so much easier. But Airflow is certainly very, very relevant here.
Yeah, it's funny you say that because when I was we've been building some different tools, of course, like, there's the whole data processing layer, right? That, you have to get data in a ready format for, an LLM to even do anything with. But when, like you said, you're generally not going to throw a bunch of data into an LLM and say, figure out this really complex question for me.
Yeah.
That doesn't tend to go so well. And then especially into that spatial data, I've seen it go very badly.
Yeah.
But when I was looking at, okay, what's the next logical way to do this? There's orchestration, and I've seen, things like, well, LangChain does little pieces, but then they have LangGraph. And I'm like, well, this looks very similar to an orchestration structure I've seen before that has a lot of things that can move data in between tasks and is graph based and has all these things. So I'm like, I'm glad to hear that. I have to check out the new SDK as well, because I think that would be super relevant, and it gives the user a lot of control, right? Of like how you want this to interact with, or what you want it to know, or how concrete you want the task to be, and error handling, and all those things that are the big concerns when you turn over questions to an LLM. So it's really exciting to hear it, because I think there's just so many commonalities between a agentic workflow and Airflow, which has these
Yeah.
graphs already built into it and has been used, and so many people know it. So really cool. Yeah, thanks for asking that question, because I was, it's always top of mind for everything. I think.
Yeah, of course.
Yeah. So to kind of wrap up, how can, if for people who are just getting started learning Airflow, what are a few good places and resources to take a look at? And then, how can they, kind of, get started and learn a little bit more?
Yeah, yeah, absolutely. So, fortunately, there's tons of resources available, and this is something that the DevRel team at Astronomer is focused very heavily on, is helping people learn and adopt Airflow. So, one great way to get started is looking at Astronomer's Academy. So we have courses and then the certifications, which are a great thing to put on your resume and also to reinforce your learning. For both Airflow fundamentals and also DAG authoring, which gets a little more into the details of some of the features that I talked about today, like assets and how you would actually go about writing your pipelines. So those are great options for folks. And we have Airflow 3 focused versions of both of those. So great way to learn about what's new in that version, if that's where you're starting with. We also have, our webinar program at Astronomer. We cover a lot of topics, including both kind of things for folks who are new to Airflow, so like introduction to new Airflow versions, or webinars on best practices and things like that, as well as more in-depth options. We've got a webinar coming up in a couple of weeks later in June on AI with Airflow. So we'll be covering like the AI SDK that I mentioned earlier, and things like that. And I think following Astronomer, like on LinkedIn or any of our social stuff, is a great way to keep up with a lot of those things. We'll usually promote them. And then in terms of actually like running Airflow, if you're looking to get your hands on it, again, I mentioned the Astro CLI is free for everyone to use. That's where I would recommend folks start locally. And then we also have a free trial of Astro, again, our managed service. So if you want to play around with kind of more of the tooling of how you would use it in production, or move beyond, just running locally, that's a great way to get started as well.
Yeah. Well, I did not know you guys had a certification. That's really cool. That you can actually
Yeah.
go through the course and get certified. So that's awesome. Well, yeah, I'll make sure to drop all those links in the notes. So if you're listening or watching this, look below or wherever the description is on whatever platform you're using. But yeah, thank you again for taking the time. It was good to dive in and kind of learn, and hopefully introduce more people to Airflow, because I think it's such a good tool that once you can really get rolling, you can see all the applications with it. So thank you again. Appreciate the time. And yeah, I'll be definitely kicking the tires on a few more things in Airflow 3 going forward. So
Awesome. Glad to hear it. Well, thanks so much for having me on, Matt. This was really fun.
yeah, thanks.